Okay guys, so now let's talk about electronegativity. So by definition, electronegativity is the ability of an element to be able to attract electrons to itself. So we talk about an element being able to attract electrons to itself. And what happens when an element attracts an electron to itself? We denote it by a negative charge, right? Now that charge is negative. There is the word negative. So this, in the word electronegativity, this portion negative was driven from this part. Okay, and then this electron, we're referring to an electron being attracted to an element, and we denote that by the negative sign. Okay, so in this lesson, I want to focus more on explaining the trends. Okay, how do you know that this element has got the highest electronegativity compared to others? So there are two ways. The first way is by knowing the electronegativity values of an electron. Of an element, not an electron. Yeah, is by knowing the electronegativity value of an element. The other way is to know the trend. No need to memorize anything. But just using the periodic table, you can be able to tell. So there are two ways. Okay. So let's look at there is what is called the electronegativity periodic table. This one, this. So on this periodic table here, so on this periodic table that you're seeing here, have you seen the values? The values are increasing as we go from left to right. Okay, and they are increasing. Okay, so try to see. They are increasing from left to right. So in the period, they increase. Let's say now listen, on the exam, they might not give you the figures, these values. They won't give you. So you need to observe the trend. So let's say we have beryllium and boron. Then I ask you, which one has the highest electronegativity value? No need to think of the values, just think of the trend. If we're in the same period, they increase as we go from left to right. So the one that is ahead in this direction, it is having a high electronegativity value. And then if they are in the same group, or when it comes to the groups, they increase as we go upwards. Okay, they increase as we go upwards, they decrease as we go downwards. Make sense? Now, something that they like asking about, which is even the reason why I'm recording this video, is they like asking about the reason, like explain the trend, like explain why is it that, why it is that the electronegativity increases from left to right. Why does it increase as we go upwards in the groups? Why is it so? Sometimes they would want you to explain the trend, like you explain the whys behind the what. Science is why we explain the why behind the what. Yes. So first, let me just try to simplify for you the trend. So we can summarize so you can be remembering it from this one. They increase as we go in the groups as we go upwards, in the periods as we go from left to right. Or you can just remember it by this one. So just draw this line, the diagonal line, and then just know that increase in the groups, in the periods. Makes sense, right? Yes. So let's now look at the reason why. And what it means is that when an element has got the electronegativity that is higher than the other, it means that it is able to attract more electron compared to the others. That's why you're going to find that chlorine can only attract one electron, right? But when you look at oxygen, it is able to attract about 2. It is because of the electronegativity, the ability of an element to attract electrons to itself. Let's look at the reason why. Why is it that, first let's begin with the trend, this trend. Let's explain it. Why is it like this? Why is electronegativity increasing as we move from the left to the right? Okay, so this is because of what is called nuclear charge. Now, what is nuclear charge? Or let me just write it here. It is called effective, this is T, effective nuclear charge. So what is effective nuclear charge? Have you ever wondered why? Okay, let me first draw it for you. So you know that an atom looks something like this, right? The structure, my bad, the structure of an atom. You have the nucleus here, right? Then you have some sort of shells, right? In the shells is where you find electrons, right? Right. Good. So these are shells. Oh, what a terrible drawing here. Okay, so these are shells, right? So in every shell, let's say in these shells there are electrons. In the first shell there are 2, right? In this one there are 8, isn't it? Okay, and so on, right? Even in this one, there might be some. Maybe there might be 1 here. So now, there is this kind of attraction that exists between the nucleus and the electron. This is a force of attraction that makes the electron to be towards the nucleus. Remember, the nucleus has got what we call the protons. The protons are positively charged. They are some positively charged here. So these protons, since they are positively charged, and the electrons are what? Are negatively charged, right? So there is some sort of attraction between the positive and the negative. So this attraction is like what pulls the electrons towards the nucleus. Makes sense, right? That is what we call the effective nuclear charge. So now that effective nuclear charge, it increases as we go from left to right. Okay. So as we go, it also increases. Now, why does it increase? It is because as we go from left to right, the number of electrons increases. The more the electrons, the more the. Let's see if we are in within the period. Okay. Okay. Let me not talk about the electrons. Okay. Just for now, just know that the electrons, the effective nuclear charge increases as we go from left to right. Okay. And now this one, since it is increasing as we are going in this direction, meaning that the one that is A, it is having a lot of this one, which will make it to even be able to attract more electrons. Okay, because the attraction is just so high. Which is, now don't just make sure that in your explanation, make sure that you mention the effective nuclear charge. But this is what it is all about. Okay, this is what the nuclear charge, the effective nuclear charge is all about. So this is what you can explain in terms of the trend, this one, in the period. Now let's look at the one in the groups. Why is it that electronegativity increases as we go upwards? Why is it so? The first thing that you should talk about, actually, since it is increasing as we are going upwards, it is decreasing as we are going downwards. I remember a question came where they asked to explain why electronegativity, that was in the story sheet, why electronegativity decreases as we go downwards. They asked that. So now look, as we go downwards, the number of periods are increasing, right? And the number of periods represents the number of shells. So it means that as we go downwards, it means that the number of shells are increasing. So meaning that let's say you have about 3 shells, right? So now look, let's say we have this atom here, the first one here. We have another one which is just having, it is just having 1 shell, which is having 2 electrons. Which one do you think will have a very large ability to attract more? Now this one, look, both of these ones, they are having this force of attraction, right, to attract the electrons to themselves. But this one, there are some shells which are kind of like obstructing. Okay, they are like seated in front of the electrons, so it's more like they are intercepting or interrupting that force of attraction, making it less. So the attraction will be less because of these electrons and these shells that are ahead compared to this one. So the nuclear charge will be felt more by these that are near than the electron that might be close. So this one has got low chances of attracting electrons to itself because of the increase of the number of shells, or you can say the increase of the, so you can mention that if you are told to explain, make sure that you talk about the increase of the shells. You can also talk about the size. If you want to, yeah, even the size, but it is because of the increase of the number of shells, right? Yeah, in some books they will say that because of the increase of the atomic size. Yeah, the atomic size increases because of the increase of the what? Of the shells. So because of this one, the electrons will be less attracted because the attraction will be low. It has already been absorbed by these that are already in front. Okay, but compared to this one, it is just having one shell with 2 electrons. It has got the affinity. It has got the ability to attract more compared to the others. That's why you are going to observe that as we are going upwards. Because as we are going upwards again, remember, the shells are reducing, meaning that the size is decreasing. And when that is happening, the electronegativity is doing the opposite. It is increasing. Make sense? Yes. And the other thing you can talk about, in your explanations, you can talk about what I've just explained. So in whatever you're explaining, talk about also what is called shielding. So this case whereby the electrons that are ahead like this, they are kind of like I use the word obstruct, right? Yeah, it's like they are seated in front of the force of attraction, making it less. So that is what we call shielding. It's like they are shielding these others that are behind them. So you can also talk about because of shielding. So you can mention the atomic size, which is due to the increase of the number of shells. You can talk about shielding. Yeah, shielding. They shield the attraction towards the nucleus, okay, or the effective nuclear charge. It's being shielded. It's more like, anyways, let me not confuse you. So just know that you explain this. If they ask you so be careful here. If they are talking about the trend in the period like this one, you focus most of your explanations on the effective nuclear charge. In whatever English you are going to write, put these. These are like the key terminologies. You know, the way the lecturers mark this is this. When they are marking, they are going to be wanting to spot these words. These are like the key words. Okay, this is the keyword. These are the keywords. At least they have to be there in your explanation. They have to be there. Makes sense, right? Yeah, so this is what I wanted to explain. So just some bonus information. Let me give you some bonus information. Some bonus. And by the way, this is why you are going to observe that group 1 and 2 elements, they don't attract electrons because remember, the electronegativity, it increases as we go this direction, right? Meaning that as we go this direction, it decreases. They have a very low electronegativity. That's why they can only donate, not them attracting. No, they don't chase; they just attract. I mean, these others, yeah. Unlike the group 1 and 2, the group 1 and 2, they are the ones that are able to give. They don't. Wait, what am I saying? Yeah, anyways, I was just trying to come up with some analogy. Don't mind. Yeah, so I'm trying to say that's why you are going to observe that group 1 and 2 elements, they can only give because it's just very low. Yes, so some bonus information I would like to tell you is also there is also what is called electropositivity. Electropositivity is the opposite of electronegativity. Everything that I've just explained about electronegativity, now the opposite. I think by just saying this, I've like explained this whole thing. So, unlike electronegativity, where the trend is like this, wow, wow. This one, electropositivity, it is like this. Electropositivity is the ability of an element to be able to lose electrons. The higher it is, the more it is able to lose. That's why you're going to find that, because it increases as we go from right to left, and as we go from the top to the bottom. That's why you're going to find that these others are the elements that are found maybe in group 7. They can't even donate. Like they can only receive. They have no enough electropositivity to give out. Okay, they have, but it's just very small. Okay, that's why they are unable to give out. They are very good at receiving, just like some of the moments in relationships. They can't give. They don't give. They are only receivers. Unless you are the one who is always giving, not even a cent. So in this case, okay. So yeah, I hope that you have understood. See you in the next lesson, and I hope that you've enjoyed the lesson. Make sure that you subscribe to the YouTube channel and um, have a nice day. And don't forget to subscribe to our platform, our learning platform, where you can access the full lessons, the rest of the video lessons, organized video lessons in biology, math, chemistry, and physics. And goodbye. Okay guys, so this is our platform where you access our materials. So you access our video lessons. So just click on videos, then depending with the term, if it is term 2, you choose the course. So we have math, all these topics, the videos are here. In chemistry, all this has been taught. So there are full lessons for thermochemistry, all these lessons. And there is even atomic structure, periodicity, chemical bonding, organic chemistry. All the video lessons are here. All these are the video lessons, even documents. We have solved materials. All the materials are here. Okay, so all you have to do is subscribe and you access all our materials. Okay, so make sure that you subscribe so that you can access our videos and our documents on our platforms.